In last lecture, we were studying Newton's law of universal gravitation. So let us just quickly review it. This law says that every massive object attracts every other massive object, and this attractive force is given by this formula. This attractive force is directly proportional to the product of the masses and inversely proportional to the square of the distance between the masses. Because of this distance squared, it is also known as inverse square law. Gravitational field strength, G, let us review it. It is the gravitational force experienced per unit mass, and has the units of Newton per kilogram. We have worked with this quantity a lot. Its value at the surface of Earth is 9.81 Newton per kilogram. This is a drawing representing gravitational field strength. You can see these vectors are pointing towards Earth, which show the direction of this force. And also observe that as we go farther away from Earth, these vectors get smaller in magnitude. Another way to represent this is by drawing circles. The value of G on each circle is constant on that circle, which makes sense because of the spherical symmetry of Earth. Let us obtain a formula for gravitational field strength using Newton's law of universal gravitation. Gravitational force between an object and Earth is that object's weight. So we know the formula of gravitational force equals mg. But now from Newton's law of universal gravitation, we have another formula, which is gmme over re square. That mass is on the surface of Earth. That is why the other mass included is me, and the distance between mass and the Earth is actually the radius of the Earth. We can equate these two quantities. We have done a similar derivation earlier, but we used that derivation to figure out an expression for mass of Earth. But right now we need to find out a formula for G, gravitational field strength. So we equate these two equations, cancel out this m and that m, and we get an expression for gravitational field strength, which is universal gravitational constant multiplied by mass of Earth divided by radius of Earth square. This formula will give the gravitational field strength on surface of Earth. If we want the gravitational field strength on some other planet, we can replace the mass of Earth by mass of that planet and radius of Earth by the radius of that planet. So gravitational field strength is directly related to the mass of the planet. Greater the mass, stronger will be its gravity, and inversely proportional to the radius square of the planet.